This video is part 4 of an ongoing series. Click on the link at the top right or go to the link in the description for previous parts. You can also subscribe to the Project Masquerade channel for updates on future videos. We can walk, we can run, and we can climb. But parkour is so much more than just running around. The more ways we can interact with the environment, the better our system will be. And it's time we added the last pieces to the player's arsenal, at least for the time being. We can walk, we can run, and we can climb. Now, it's time to fly. Welcome to Game Mechanics Explored. Last time, we gave the player the ability to climb up walls by utilizing our platform scanner to detect viable ledges to grab onto. You'll notice, however, that these rays always cast in whatever direction the player is facing. The system is only meant to detect ledges on about 90% of the flat surfaces that the player is likely to encounter. But what about the other 10%? What about the curved walls? What about corners? How do we get from here to here if our platform scanner doesn't go there to detect a point for the player to travel to? What about corners that stop the scanner by sitting slap bang in the middle of its range? We need a way of detecting these corners, or really any surface that isn't flat. Luckily, we still don't have to modify the original platform scanner, and we can simply use the data that is already there to do all of this. These outside corners are the easiest because they work similarly to dismounting. When we point our analog stick in this direction, the platform scanner isn't likely to detect anything. We know from last time that our scanner returns information in a certain way if nothing is found, and this is really no different. The only clarification we want to make here before moving on is that by using the same check, we open up the possibility for glitches. We need to further clarify to the code that the upward dismount and the outward corners are two different things. This is why we checked last time for the position of the analog stick when the player wants to move. If the player wants to go up and onto a ledge for an upward dismount, they will most likely point the analog stick straight up. As a result, the x coordinates will likely be 0, or at the very least very close to 0, and the y coordinate will be closer to 1. Conversely, if the player is trying to go around a corner, the analog stick will likely be in the opposite situation, with a higher x coordinate and a lower y coordinate. By setting the boundaries as if statements and having our code check for the analog stick's position before allowing the player to move, there is now very little chance that the code can mix these two instances up. If both conditions are met here, then we cast an extra ray in towards the outer corner to ourselves to make a new point to move to. When I talk about creating a new point to move to in these videos, I just like to point out that it always works the same way as it does in the first video. We use an initial ray to get the lateral coordinates, or the x and z position, then we use a downward ray cast to find the final y position. All of these positions are then taken and used to construct a new point. I'd like to take an aside to note how I want to structure this new script, and why I feel this newer version works better than the previous version I made last year. When considering how this system works, we have to think of it as logic for the player. The player can make decisions based on a variety of different factors, and very often I find that those factors oppose each other. The parkour can either be above or below the height boundary. The player is either climbing or not climbing. Most of our movements take place under those conditions. This is why the code is nested like this. I wouldn't say nesting is more or less efficient in terms of performance, because it isn't. The way this system has to operate favours this kind of nesting, because by feeding our decision making down through check after check after check, we just get more and more accuracy in the system. We also avoid rampant repetition. If, let's say, 10 of our movements take place under the height boundary, why would I check the height boundary 10 different times, in 10 different if statements? I can just keep them all under one statement, and if anything takes place above that boundary, it can be kept underneath the corresponding else statement. I like to structure it this way because it's like checkpoints for bug testing. By adding little markers in between all the checks I perform, I can figure out precisely where the code is failing if it ever does. It also means that everything will lead down to something eventually. Dismounting upwards onto a platform and going around an outside corner are both sorted using the same check, which is a null lateral scan. We can keep both of these actions in the same if statement, rather than unnecessarily repeating that same statement. Once they are both together, we can further nest them by separating them with their own checks, which very conveniently oppose each other. Again, it's a hard thing to explain, so on screen are two examples of code. On the left is how I would have written this code before, and on the right is mostly how the code looks now. The one on the left might look more organized to some, but the one on the right is actually far shorter and far easier to debug. It mostly just comes down to legibility for the programmer, and I feel like this code just works better and has been far easier to program than last time. Just a little side note, I know there's a lot of discourse among programmers about which practice is best for things like this, and I think this way works the best, for me at the very least. Inside corners are a different kettle of fish entirely. In fact, we don't even need the platform scanner at all. When we set it up for climbing last time, we pointed a raycast in the direction that we pointed our analog stick, and then put the boundaries of the scanner along that line. What happens if a corner next to us falls below even that minimum boundary? Well, this is a raycast. It will still return the results that we ask it for. And the two results that we want are where it hits and how far it travels to get there. With our raycast distance value, we can check what number it returns. If that number is above a certain threshold, or in this case, above the minimum boundary for the platform scanner, then we allow the scanner boundaries to be defined and let it operate as normal. If that number is below that threshold, then we instead work with the point returned by the ray itself and begin constructing a new scan point for our player to move to. Whether it's a corner or a flat surface, it doesn't matter. Those checks are only done to ensure that we get the point that we need. Moving to those points while climbing, as I said before, is all contained inside one neat little method. Once all of our checks are performed and everything lines up, we just call the method from before, and now we can move around corners. Curved surfaces don't actually need any additional code, because we practically have almost 360 degrees of climbing movement. The checks we perform here work at pretty steep angles that I can't even see myself realistically using in the future. With a couple of extra conditions in the code, we have vastly expanded our range of movement while climbing. But I did say almost 360 degrees. We don't just want almost. We want the full range of movement for our player. We can climb along flat surfaces, we can climb on curved surfaces, and we can get around some pretty sharp corners. Let's take a look at getting our player to walls that they aren't even attached to. While we are idle and in a climbing state, we can let the player ready themselves for a backwards jump. When considering the inputs on a common controller in terms of programming, most of the buttons are booleans, true or false values that tell us if the buttons are being pressed or not. Some of them, though, are referred to as axes. Our analog sticks, for example, have two axes each, one for the horizontal axis and one for the vertical axis. Both of these axes are returned and used to construct the left analog stick's coordinates that we have been using throughout this system for various purposes. The triggers on the controller, or the L2 and R2 buttons on the controller that I'm using for testing, also use an axis to store its current position. If our trigger input is all the way up and not being pressed, it will return a value of 0. If it's pressed all the way down, it will return 1. By using this value in our animator, we can transition between our idle hanging animation and this backwards hanging animation that tells the player they can now perform a backwards jump. If we press the X button while this is our current animation, we can trigger a new one to play and call our jump method from before. That's all pretty simple, but now that we're in the air, the versatility of our platform scanner comes full circle. Because we aren't technically in a climbing state anymore, the platform scanner returns to its default state as if we were standing. This means that the scanner will start looking for viable platforms in front of the player, and if it finds one, it'll create a new point for the player to attach to, which again is all done by our little method. We can now jump backwards from a ledge and onto another, right back into a climbing state again. I never said it in the first video, but this also works for ordinary jumps as well. We can see now how taking the time to set up our code this way has benefited us in the long run. Even if the checks we need to perform are always different, the data that's needed to perform those checks is likely already there to be used. Even if the movements are mostly different, the ideas behind them are mostly the same. So even with 15 to 20 unique movements, they can be pulled off using the same 3 or 4 methods, and further refactoring can only bring that number down. Even if I don't have the animations for a lot of the movements I want to include in the future, I know that I'll be able to use these methods again. I know that the platform scanner will continue to come in handy, and I know that when it comes to expanding this system, it will likely be a breeze, because the framework is already here. With that out of the way, all our climbing state movements are complete. As we return to our grounded state, there is one more movement I want to give the player. Wall running is a mechanic that made me fall in love with Prince of Persia: Sands of Time. It just feels really cool to run along the side of a wall and jump off over a death drop to land back on solid ground. I feel like my system just begs for this mechanic, so let's see what we can do. To start off, we need to know what walls can be run on and which ones can't. Unfortunately, there's no easy way to do this. If we make it that every wall can be run on, players are likely to get themselves into some pretty wacky situations, and if we resort to extraneous setups for each and every wall that we can interact with, it would take ages to actually set everything up. Of the entire parkour script, out of every movement we can perform, the wall running takes up at least a tenth of it, and most of that code is just getting as much information as we possibly can just to get the player to behave properly while they're on a wall. Like before, the actual movements are very simple. In fact, the wall running is very similar to the previously discussed cover system. We use the platform scanner to get the position and the angle of the wall, then we just let the animation play out while the code keeps the player's position and rotation correct. We can even use the same logic for jumping off the wall as we did for backwards jumping. It's all just a matter of calling those same methods. The real difficulty here is everything surrounding those methods. We have 3 things to take into consideration here. Scanning the walls before we start running, or the entry, making sure that the player has the correct interactions while wall running during the execution, and everything concerned with properly exiting the wall run, no matter how the player does it. If we're being realistic here, the player isn't going to have as many opportunities to wall run, not as much as they might use their other abilities. Even still, we want to maintain some sort of dynamic aspect to this system. Prince of Persia could get away with it because the level design was better suited for it. I wanted a more natural feel to the environment, so there is going to be a lot more geometric density, which will further confuse the platform scanner if we try and go off of it alone. Realistically, how do we separate a wall that looks like we can run along it from a wall that has features on it that would stop the player from performing this action? The player might know that they shouldn't try and run on it, but I'd prefer that they don't have the chance to begin with, even if they wanted to. We have no way of effectively and efficiently separating surfaces like this, especially when it's just for one mechanic. The solution that I came up with is probably not the greatest, but for now it serves its purpose. It allows us to maintain a dynamic system while keeping the extra steps to an absolute minimum. As we approach a wall, there's a couple things we want to happen. First, we need to check which side the wall is in relation to the player, left or right. We do this by casting 2 rays at an angle from the player and checking which is longer. If the right one is the longest, the wall is to our left, and vice versa. Then we let the platform scanner do its thing and scan the wall in front of us. If a certain number of these hits have a cast distance that is the same or very similar to each other, then we have confirmation that at the very least, the start point for a potential wall run is flat and is spacious enough for the player, and is therefore viable to initiate a wall run. This is only the first check. Now that we know a wall has the potential to start a run, and we know what side it's on, we define a new point as an origin and cast a ray along the width of the wall. The direction of this ray is based on both the angle of the wall and whether the ray is to the left or to the right of the player. This ray gives us some basic information, but the only thing we need is the point that it hits and the distance. If the distance is too low for my liking, the wall run is not viable and is stopped from triggering. If it's high enough, we take the ray's origin and the hit point, and just like the platform scanner, we generate a bunch more points at regular intervals between those two boundaries. We then cast rays towards the wall and check their distances. Again, we want to know if these distances are equal or equal enough to each other, which tells us that the wall is flat enough to perform a wall run. We could even go further and make this even more accurate by performing a check on the width of the wall for every one of the initial platform hits. But given that that has the potential to snowball into hundreds of raycasts, and having to dynamically generate hundreds of origins for them, I'll just stick to one check. If it turns out that Unity can handle dynamically spawning hundreds of raycasts and comparing hundreds of numbers without completely wrecking my frame rate, then I'll do just that. But for now, it seems like a little too much for my PC, so I'll shelve the idea for later. If our wall is found to be viable, we can now let the player trigger the wall run. So I'm going to add this as an addendum to show that even when I have a method programmed and explained in a script, it can and should always be subject to change. And that I am an idiot. See that previous method for scanning walls? Forget it. The idea that I was using so many raycasts to scan a wall seems pretty ridiculous now. It's been shown that the initial 15 rays can get us pretty far, and after thinking about it, this method shouldn't be an exception. Rather than spending all that extra code generating these points and pointing a lot of rays at the wall, why not just scan along the surface? It's a small change, but one that uses far less code. Now the system simply scans along the length of a wall and returns the necessary information. If it bumps into any obstructions, then no wall running. And if it doesn't, then we're free to pull it off, now with far less raycasts hogging up performance. While the player is running, there is one main variable we want to work with. We need to know, for various reasons, how long the player has been running along the wall. When the wall run animation is playing, we have a small timer that will only count up if the animation is active. We call the jump method again to give us a little bit of a rise, and because the character controller is still active, it'll begin to pull us back down to the ground. There's a bit of trickery here when it comes to the movement, and the intended result actually happens because of an oversight that I left in by accident. The platform scanner doesn't stop while the player is running along the wall, and it's always finding a position for the player to move to, but the animation is always moving the player along the wall. It's the same when it comes to the player's rotation. The effect of this is that the player is sort of magnetized to the wall, as long as I tell it to. It will stay stuck at a fixed distance from the wall. I say that it's a glitch because the code that moves the player to the assigned point is still ongoing, but the animation has root motion, meaning that it's also trying to move the player. Instead of one cancelling the other out, they somehow combined to create this effect. It works, so I'm not going to complain. While the animation is going, we check the timer. If enough time has passed, about a second and a half to be precise, the player is now able to jump from the wall, which functions exactly the same as the backwards jump from earlier. Because of the timer, the constant presence of the platform scanner, and the character controller always checking if the player is grounded, we have multiple methods for telling the player when they should and shouldn't be wall running. As stated above, there are multiple exit conditions for the wall run, one of them being a wall jump, which is the only one that the player can actually activate by themselves. The next one is the timer. To stop the player from running along the wall forever, if the timer hits 1.5 seconds, then the wall run will stop and return the player to a relevant state, whether it's falling down or just standing. The next one is the character controller's grounded boolean. If this returns as true, then the player is close enough to the ground to be classed as standing on it, and then the wall run will end and transition the player to their standing state. It's worth noting that the wall running animation actually alters the player's forward direction to face the wall. When they exit the animation, they will again be facing the wall, which doesn't look right. When I trigger the exit conditions, I make sure to adjust the player's angle while they're transitioning to their next animation, and making sure that the transition itself is as smooth as possible. But this is the problem with using animations that aren't mine, because this doesn't always work. Since we have a scan constantly pointed at the wall, we can also tell the player to exit from a wall run if the wall suddenly isn't there to be scanned. The last way the player can exit a wall run is by finding a new ledge to grab onto. Again, this works similarly to mounting ledges while airborne. The platform scanner finds the wall in front of the player, creates a new point to move to, and once the player is close enough, they attach to it. The wall run works well, but it's definitely not airtight. There's still a lot more work that I want to put into it to make it the cool mechanic that it should be. I mentioned in part 2 of this series that there are a few things that can't be sorted by the platform scanner. This includes things like ladders and pipes. These are both things that the player can reasonably climb, so why not let them? It adds more variety to the system, it can be a natural part of the environment. I also like the potential that adding these kinds of things would bring. If the player jumps from a platform and towards a wall, the only options they have at present are to keep falling or to grab onto a ledge. Imagine how much more I could get out of the system if the player could grab onto pipes or ladders or anything really. Another whole area of the system that I can't create yet is swinging. This is another thing from Prince of Persia that I wanted to do as well. This includes swinging from bars, ropes, branches, basically anything horizontal. But I also wanted the players to have a quick and snappy way of getting around some corners. Let's say the player is running along the side of a building and comes to something that's hanging from the corner, like a sign or a lantern. Why not give the player the ability to swing on it to get around a corner? I think it'd be pretty cool, and if the player is running around, it maintains the pace of the system, which is always good. Both of these, again, like Prince of Persia, can be worked into the wall running as even more exit conditions. Now, instead of exiting a wall run by just jumping off or reaching a new platform, you could be able to attach to a ladder, pipes, bars, branches, anything that your eye can think of. If the player can reasonably stick themselves to it, then why not consider it? Sliding is another area with a lot of potential. I mentioned before that I wanted to use sliding as a way of stopping the player from jumping off ledges, and instead dropping to hang from them. I also mentioned last time about further animating the player's interactions with slopes. If a slope is too steep for the player, then I want to trigger a slide. While sliding, the player could trigger something akin to the backwards jump, and let them grab onto platforms. Again, this will increase the variety of movement options for the player, and it will let me diversify the actual environment itself. Speaking of diversifying the environment, you might have noticed that the number of opportunities for the player to actually use the parkour system decreases in these wooded areas, and that simply won't do. I want to give the player the ability to interact with more things that exist as a natural part of the environment. We can get them interacting with rock structures, but the potential is there waiting to be realized with things like trees and caves. Parkouring around a forest would be a nice juxtaposition compared to parkouring around a city. Again, this will also let me squeeze in more variety to the system and the level design. Due to the nature of how city maps can be structured, I already know how these maps will look and interact with the parkour system, but it honestly excites me to think about what I can do with field and hike maps. Imagine the kind of verticality I could get out of a forest environment. It's why I keep saying the parkour system is only halfway finished, because I don't want to admit that the more I think about it, the more that comes down to about a third. The next one is a little hard to describe, but transitioning animations are another big thing to consider. A parkour system will completely fall apart if it has no pace. It's naturally going to speed up and slow down as you go from running around and jumping to the slower climbing sections. The main thing that will maintain that pace is how smooth the transition between those peaks and troughs feel, and that is achieved by having really good transitioning animations. Getting around these dense and complex environments needs a strong emphasis on animation to maintain that feeling of flow that Prince of Persia had. If the animations snap back and forth between each other, the player isn't going to feel in control of their character. Another small addition would be different climbing animations. Currently, I only have these animations where the player has their feet to the wall, which is known as a braced hang. I don't have any animations to pull off the opposite. Some walls won't allow the player to have their feet placed in this way, so having a set of animations where the player has their feet hanging down would allow me to really sell the look a little bit better. The setup wouldn't be too difficult either. I could just cast a single ray below the player to figure out which set of animations needed to take place, then simply tell the player to go one way or the other. Animations really are the sticking point of this system. I'm looking into manually animating as an option, but looking at just how far I can take this one system and the animations it would take to pull off, animating these things by hand would just take far too much time. Taking all the other systems into account as well, it would be pretty much impossible. My only other option is of course motion capture. With the growing availability of motion capture systems to general consumers and the sheer amount of things that we can do with them now, it's really the only option that makes sense to me. The parkour system could be practically doubled if I had the ability to make my own animations. And that's just one system, one game mechanic. Unfortunately, there's a lot of setup, a lot of research, and most importantly, a lot of investment that needs to go into something like this. It's not just getting a bunch of mocap cameras and a stylish suit. It's about getting a whole rig to house these cameras. It's about getting set pieces created to actually animate myself climbing on. It's getting a big enough space just to get this all working. Professional mocap studios are in huge open spaces with a lot of equipment and technicians and actors working in tandem just to make a single animation. My project is tiny at the moment. I don't really feel like I've shown enough of what I can do to really justify asking for that kind of investment. I haven't proven myself yet, so all I can do for the time being is move on and make as much as I can on my own, until hopefully there comes such a time when I'm lucky enough to do this properly. It's an option that I want to work towards, but it's not something I can really do at the moment. So, the parkour system is going on the back burner for now. I'll continue to tinker with it and streamline the code a little bit more, but I've pushed it as far as I can. And until I can push it further, we can still make other mechanics. We might be able to climb around, but it's all for naught if the player has no reason to move around in the first place. You know what? It's too quiet. Let's keep it that way. Join me next time, whenever that may be, as we take a look at the stealth system. Thank you for watching, and hopefully I'll see you soon.